All right, guys. My name is Owen Nix, and I just want to kind of start us off on this webinar series that we're going to be doing to hopefully help you guys in your virtual classrooms and in your regular classrooms, depending on your situation. But today I was just going to talk a little bit about reaching our virtual learners, let you get to know me a little bit, and kind of my experience so far in the virtual world. So a little bit about me. I grew up in Kennesaw, Georgia. So Cobb County area, north of Atlanta. And after that, I went to get a chemistry degree at Georgia Southern and my MAT from Southern as well. Currently, I live in Pooler, Georgia with my wife, Lindsay, my 6-month-old son, Cohen, and our dog, Magnesium. And I teach chemistry, physics, and physical science at Effingham County High School, and I teach both virtual and in person. I'll kind of get into my story with that in just a little bit. So the question is, how do we get these online students to buy in? When they're in person, it's a lot more easier to get to know them and, you know, ask them how they're doing and different little things we use as teachers to not only get to know our students, but let them know that we care about them and that really we're here for them ultimately. Like, yes, their scores matter to us and all those other pieces, but really we care about them first. So the first place we have to start before we can look at, you know, how are we going to present certain content and things like that is we just have to focus on them. That social emotional piece is huge too, especially now since we don't have the opportunity to see them in person and may or may not see them on screen, depending on what your district's rules are with that. I know in my district, I pretty much only see them on test days. That's when they turn their camera on. But other than that, you know, their faces are known to me just through the grade book. So it's important to realize that the academic piece, it'll be a lot easier once we get to know who they are and are really intentional about that. And once we have that kind of rapport with them, it becomes a lot easier for them to ask questions and come to us, and a lot easier for us to go to them about different things as well. And it's not just some words in an email. There's actually, you know, somebody you're recognizing on the other end. So the social and emotional piece is really huge, which I'm sure, you know, you're familiar with. It really is just good teaching in general, but just doing little things that are not necessarily academically based to help get your students comfortable with being in your classroom and also make them realize that you don't only care about their grade in the grade book. So having little thought-provoking questions or something like psychological to kind of make them think a little bit and really just tell you more about them. I think it's also good to offer an opportunity for them to answer these, you know, outside of just in the meet, like where you can speak with them one-on-one, or it can just go to you, because I think that's also when we find out if there's something going on with students that, again, we're not, you know, getting to see, that we need to dig a little bit more deeper into. Even something as simple as asking what their interests are, or sports or music. I mean, that can just lead to a student opening up to you and not only doing better in your class because they know that you care, but also more comfortable to share and be kind of honest with you about things. So I always try to, even if it's just at the beginning of class or maybe in the middle of our notes or something like that, I always try to give the students an opportunity to kind of take a brain break and think about something else for a moment before we move back into material. If they're just sitting in front of a screen all day, I know they're, you know, pretty worn out from watching and listening over and over again to different academic things. It's important to focus on that social and emotional piece as well, and make sure they're in the best state of mind to receive instruction. So outside of that, why we're teaching or what we're doing to reach them, I just want to share a little bit about my virtual story. My virtual teaching marathon it seemed like it's been, and it hasn't even been halfway through the year, actually didn't start for me until 4 weeks into school. I was a completely in-person teacher. I had 2 physics classes, 2 chemistry classes, and a physical science class. And we started in my district in Effingham County, we started on the regular old first day of school. No delay, no anything like that. We obviously had the virtual piece for students who aren't comfortable coming back in person, but outside of the teachers that were assigned to that, everybody else was in person. Probably about 20%, 25% of our high school came back on campus. So for 4 weeks, I basically had my schedule I had prepared for all summer. I wasn't planning on teaching virtually, and they had let us know pretty early that we wouldn't be, those of us who wouldn't be. And so I was just rolling, and all of a sudden, 4 weeks in, 3.5 or so, they told me they were going to take a physics away and give me an online physical science. So as most of you know, it's almost like having another prep. Just because how I was presenting things to my in-person physical science students just wasn't the same as I present it to my online kids, which is completely understandable, but it required a whole different method of thinking. And originally, when I started, I just was doing what was easiest for me. So I tried a few things that I had done in class, but pretty much it turned into, for the first 3 or 4 weeks of me teaching virtually, I would go over the notes with the kids. I'd give them some fill-in notes. They'd have some stuff to do on their own, and then it was kind of just up to them to get the material and then fill out a study guide and show me what they learned. Now, I made some other videos and things to help them with the material I assigned them and things like that. But again, I had all these in-person classes. I really didn't have a lot of time to devote to this class because it actually only met for part of its allotted time because I had a 6th period in person that overlapped with it. So it really just became pretty vanilla for them. And of course, they didn't do well. So my typical meet would be, and we're Google. So I would go over a bell ringer warm up. We'd fill in some notes, or they'd fill in notes. I would just talk through the notes. I'd give them some reminders about assignments when they were due, and then I'd just open it up for questions. And of course, there never were any questions. And then on their own, they had some worksheet to do, or problems, or a virtual lab, or something of that nature. So that obviously didn't work very well, as probably a lot of you have experienced if you have virtual classes. So what that created is a class where I really didn't have a lot of learning taking place. The students, they were there, they'd show up sometimes, they would listen maybe, or who knows what they're doing behind their black screen. And then they would remember, recall, and then repeat. And that was just the name of their game. Remember what he said, recall it when he asked, and then just keep doing that over and over again. And of course, that translated into pretty low test scores and really little understanding. When these students came to me from their previous teacher that was virtual, she had a really large class, so they separated her class and gave me half. I would say, 70% were not passing, and probably half of those were below a 50 and not doing much of anything. So not only did I have this issue of the kids who were showing up were struggling, then I just had a bunch of kids who had no desire to show up and no desire to even attempt it. So obviously that was an issue for me. I wasn't going to go through the year accepting just all these students failing, even if I could barely get them on meets and things like that. I wasn't going to give them the out that we're just going to go through the motions and this year is what it is. So I changed up what I did, and really it just went back to some of the things I was doing in person and how I can translate that and reach these kids that aren't in my room, that I can't share my love in person of science for. So I just kind of went through and asked myself some things. What will help me, or what will help my students? How can I get learning to take place versus just telling them about what they need to learn? How do I create some deeper knowledge, right? They'd answer questions and things like that, and I could tell that, I'd have a couple free response questions on a test, and I could tell they just went and found like the keywords from some other questions and tried to piece together an answer they didn't understand themselves. And then how can I give these kids who are not in person, who are not in my science lab with my in-person kids, a chance to be scientists, right? I mean, we have this picture on the left. This person has all these tools and this equipment, and they're investigating, but they don't have that at home in a lot of cases. In my district, we're pretty rural. We're outside of the Savannah area, so I have kids who live in like this local city and town, and then I have kids who live 30 minutes away, 40 minutes away from the school, in towns that have 100 people. So it really is quite spread out as far as what they have available to them. So I first had to figure out ways, to provide things or provide ideas for them to investigate stuff with things they might have. And then, of course, if it was a student who truly had no access to any of that stuff, or was going to have to do some, go here to do it, or go to this grandparent's house or whatever, I wanted to give them an opportunity too. So I started to get back to that phenomenon-based approach. The same approach I use in my classroom. It's just in my classroom, I provide a lot of materials. So a lot of the structure that, you have kind of comes from that. Well, online, they may not have the materials, so I've got to figure out ways to use what they might have, right? I feel like, obviously a much smaller scale, but I feel like the Apollo, right? Where you're looking at, here's all the stuff they have. How can they do this, right? So it starts with a phenomenon. So we got to figure out something that they can kind of investigate. Doesn't have to be big. Can be the simplest thing that you wouldn't even think a kid would even notice, and just ask them some questions about it. So it could be one lesson, right? It could lead, and I could refer to it one day. It could be something I refer to throughout a whole unit. It could be something that I refer to next unit. It doesn't have to be this phenomenal thing, right? Phenomenon aren't necessarily this huge, elaborate production. It can be something pretty basic, but it's just something that can get the kid to wonder a little bit about what's happening. And that's all you really need. So a lot of times, this doesn't have to be something they have. It could be video led, which is good. But I think it's important to have a little bit of both. Some things they can do in person that they have the ability to look at and observe at their home. And then some things that you present to them, maybe some more complex things that you present to them via video. And I'll kind of go through an example of that in just a minute. And then, of course, you got to remember you can always clean it up later. Like when they answer your question the first time relating to their phenomena, you're going to get a wide variety of things. So my example I used, I'll share a couple of things that they sent, but really you have to remember it doesn't really matter where their thinking starts. It's just the fact that they're thinking, right? So we just want to get them thinking. And then once we do that, once we get those wheels turning, then we can start to help them navigate and get to where we want them to get. So my example that I chose was related to Charles' Law. And kind of before I talked about anything, so we did, just to give you a little background. So we did matter, like solids, liquids, gases. The kids have learned that forever. It's pretty straightforward to them. Probably still some phenomenon-based stuff I could have done there, but again, it's one piece at a time. We're still trying to travel while we fix fix everything that's going on. So I chose Charles Law, and I was like, well, how could they, look at this in person? Like I have different ways I present it in the classroom, right? I have lots of different things, I can provide and stuff for them to investigate this in a way that I want to. But what do I do if a kid, doesn't have, like, I don't have a balloon at my house. I don't have different things. So, and I certainly want to also make sure, students are being safe. A lot of these kids are home at the high school age, home, and their parents are at work. So it's not like I want them doing anything that any unauthorized experiments at home and causing any issues. So there's still a lot of phenomenon-based things we can do with gas laws and other topics related to gas laws, like kinetic molecular theory and stuff like that, that are phenomenon-based. They're pretty basic, and we still have a lot of application from the example. So my example, what I wanted to do was figure out something they could do at home with very little materials, and if they didn't have access, still were able to investigate it as well. So I just asked the question, what will happen to air as it cools? So I had my virtual students blow up a balloon. They could use a rubber glove, which a lot of people have now on hand, a bag, so like just a sandwich bag, or a water bottle. And they had to take a picture of it. Now, if it was the bag and the water bottle, I told them it would be best to leave it in the sun for a little bit and let it really warm up before they put it in their freezer. Or, I had some students say, hey, can I just leave it out overnight and observe it in the morning? And I was like, yeah, because that's going to get just as cold some of these nights we've had lately. So I asked them to place it in their freezer and then go check it in 30 minutes. And like I said, some of them, observed it the next morning if they let it outside. And then after they looked at it, I just asked them to take a picture and submit the 2 pictures. And I didn't ask them anything else. I didn't even ask them to answer the question yet. I just wanted them to do that. And I think I just put an assignment up for it to be due the night before we met. So just for them to do and make their observation. And I don't even, some of them, I didn't ask for an observation. Some of them gave me their observation. But just for them to do that. And then, so here's a couple examples of what I got. So I've got on the left there's just a sandwich bag, and they blew it up. And I think I didn't include this picture, but some students just blew up 2 bags, like as much as they can, and then compared them after. But I didn't even have them do that. That way, if they had one of the item, they could do it. So this is before. I think that person did leave it in the sun, so it would inflate a little bit more and warm up. And then they put it in the fridge and took a picture of it after. They didn't take it quite at the same angle, so you can't really, it's not super obvious that it's not as full, but I think you can kind of see that it doesn't bulge as much. And then the glove is a little more obvious with it being with the elastic aspect. So you can see how it's kind of elongated, the air's up into the fingers, and then it kind of backed down as it was put in a fridge. So these are some submissions I got. I got lots of other pictures. Some, were grainy and I could barely tell what was happening. But the point is that they sent them. And then I had some, who didn't. But I still wanted them to be able to, make some observations, check out the phenomenon, get their wheels turning. So I used an alternative video. And I always try to find videos that have little to no explanation. So this one, the guy maybe says 2 words and he doesn't tell you really what's happening. He just pours his liquid nitrogen out of the cup on there. And I just asked him to watch this and make observations. We'll watch this real quick. Right, and so like we'd expect, you get this crumpled looking balloon. And then as you pick it up, it warms and starts to take its shape again.
all the way up. It is. Make it.
So eventually it warms all the way up, and now you have the original balloon, which still, even though I know it's happening, is still cool to see. And so a student who, maybe they've never seen that before, or don't even know what liquid nitrogen is, they're going to have some questions about that. And so that's why we go back to that original question. What happens to air as it cools? And hold on. There we go. So how did I use that in my lesson? So I started out the next class after they had, they had either watched that video. I think the kids who watched that video, I made them write an observation. So I'm pretty sure I made both kids give me one observation they had of the bag, because I wanted the kids who watched the video to also have some observation, since they didn't tangibly have anything to do it with. So I did that in Pear Deck, and Pear Deck, if you haven't used it before, it allows you to, basically get real-time responses from your kids. You can set up multiple choice answers, where if you want to guide them a little bit more into some answer choices, you can set up a more free response based lesson, or you can, the best feature I think is have them draw, which I love using. I tried it out a few weeks before this in my online class, and it was perfect for how particles are moving and all that kind of stuff. They could draw a picture, right? So, but I chose to use just kind of the open-ended response, free response. I put, what will happen to air as it cools? And I got a ton of answers. I got the general, like, the particles are going to move slower, or, some people only thought about it in regards to the balloon. Some people mistakenly said, well, it's losing some air, which isn't true. So those are some things, right, that, again, weren't correct, but they're thinking about it, which is the whole point, right? Get them thinking. So in the lesson for that day, I just built in questions that continuously referred back to the phenomenon after we learn a piece of instruction. So some of the questions I built in, right, so we talked about the gas laws, talked about particle movement, things like that. So just these are some of the questions that just were built in, and some of them are even from other parts of the unit that I still referred back to this at. But said, what happened, so some specific ones, what happened to the volume of the balloon in the freezer? Why did it expand after it was removed from the liquid nitrogen? So I wanted to make sure I asked questions that, both sets of kids felt like they had an answer to. I didn't want to just ask about what I put in the freezer and what you did at home, because I didn't want the kid who didn't have the opportunity to do that to be like, oh, well, he doesn't care about my response. And in the same regard, the kids who put their balloon in the freezer and may not have seen a lot of change could watch the liquid nitrogen and really see a change because of the huge change in temperature. My favorite question I asked was draw the particles before and after. So this one I had, a variety of things. I had some kids, use little arrows to show that the particles are moving more before and after. Some kids drew like one particle and an arrow and said, times 10 or something. It was kind of funny. But all these little questions, I referred them back to that original phenomenon that we used. And then, of course, as we kind of went through, I gave them kind of, what do you think would happen if, so to different scenario, not air in a balloon, but what do you think would happen if, and then I asked them a question about the air in their tire or something like that, which for students of their age is very important because a lot of them are starting to drive, so they do care about their vehicles, I have realized. So those are just some questions I had worked in through this whole thing. And now you could even use some of these as free response questions on a test, right? You could have those students think back and say, explain Charles' law in relation to your balloons that you, or the balloon you placed in the freezer, or the plastic bag you placed in the freezer, or the bottle, right? So just things to get them thinking. So other applications of the same phenomenon was I could relate it to kinetic molecular theory, right? We talk about particles. Most of those kids begin to understand those particles aren't moving around as much. We can talk about kinetic energy, which obviously relates right there to kinetic molecular theory. But anyway, temperature, how it's a measure of how much those particles are moving, right? How much energy is in there. And then, when we get to phase changes, right? How the particles are moving in each phase, they can kind of see how, okay, when the gas cools down, they're going to not be moving as much. And eventually that movement's going to become so low that it's going to be a liquid. Now, not in the case of air, they have to get down pretty low, but looking at some of the other examples, they understood the different particles and how they looked in the different phases. So again, even though it wasn't really in that day's lesson, I was able to refer back to it as we went through the rest of that unit. And you could certainly do it before, like if I, in my unit, was not going to teach gas laws till like the end, I could always have them do that on the front end and still ask the same question and then refer to it. And then basically just at the end, they would be able to connect it that it's Charles' law. So there's no real rule with where you have to put it. You can do it before all these things as well. So phenomenon, right? So where do we find them? So you're not always going to be able to figure out a way for them to do something at home safely. So how do we get to some other ideas about phenomena? Because I certainly don't have an idea for every topic yet. I'm still working through that. And some of the ideas I used last year, I didn't really like as much, and I'm reworking them now. So the GSTA Bank is a great resource if you haven't been on there yet. The nice part about it is that you can, and ignore all my tabs at the top. That's actually pretty mild for me. So if you go down in here, you can pick your topic, but I like to remind people that, if I'm on physical science, there might also be something in physics that's not in physical science that I could use, especially for my physics and chemistry classes. I love going to my physical science stuff because a lot of times it's some of the more basic concepts, and that's where like a lot of the phenomena, really step in, because you're just trying to get these kids to, again, think a little bit and wonder a little bit on a lower level. So there's some examples there for you to look through. There's also the wonder of science, which is pretty good. Kind of laid out the same way, a little bit. It's not as tied to our standards in Georgia, because the other one was a Georgia GSTA resource. But still some stuff in here that if I knew what I was trying to teach, I could find some different things like second law of motion, gravity, right? All these types of things that come up in physical science, as well as chemistry, right? We get different things with thermo going on, and energy and molecular level structure and all kind of different things. So lots of stuff there. And then the last one on there is Phenomenon Library. And that's a good resource as well. If you just Google phenomenon based instruction or science phenomenon or any of that kind of stuff, you'll get a lot of different hits and a lot of things that people have created. I every couple of weeks Google it because it seems like something new is, if I scroll down a page, something new is up there. So there's a lot of stuff out there that you can use to help get these kids thinking and wondering a little bit on their own before you teach and kind of hone in their learning. So some other ideas just I had for engagement. I don't know what you use in your district or what you may have available. I use my chat a lot. If they're not comfortable, we have something called GoGuardian, which is basically a software for us. It's really to monitor them and make sure they're kind of doing what they're supposed to when they're in our classrooms. But it also allows a chat feature where they can send me a private chat message so their other students can't see it. And honestly, in class, this is really big too. I have a few students who, they just deathly afraid of raising their hand, but they will send me questions on chat all the time. And I've really found that it's helped a couple of those kids who've been struggling, because that's really why they don't ask questions. They don't want anybody to know. Of course, breakout rooms. I would not say I'm a pro with breakout rooms yet. I'm definitely still trying to learn with that. But if you are, I'd love any tips with that. I'm still kind of investigating it myself. I do use Pear Deck a lot, and I kind of already shared why I like that. It's a different format for questions. Kids don't know what the other kids answered, so they're a lot more apt to answer instead of I have a class of 20 and 5 people respond. And then it's also what's kind of neat is they can change their answer as they go in. So like if it's a multiple choice, and as I'm explaining it before I really give them what the answer is, you can see kids going and changing their answer because they're like, oh, I just heard what he said. I don't think my answer's right anymore. And they'll kind of figure it out on their own, which I love. And then Google Docs and slides. Obviously, Kami is a great tool to be able to write on things. Really, it saves me. I was kind of sharing this earlier. But it saves me a lot because if I accidentally upload a PDF, kids can still work on it and it doesn't slow them down, or I don't have to, they don't have to wait on an email from me with the fixed assignment and stuff. And then of course, digital boards where they can kind of collaborate and share together, and then any way we can get student feedback. So like I said, I really like the Pear Deck platform, but there's a lot of good stuff out there. And this by no means is all of them. I just want to share a few things. I'm sure a lot of you have seen these already, but just some things that if you're looking for something new to investigate and kind of try out here before the Christmas break and after winter break and all that stuff, there's some things there to kind of look at. So, all right. Well, I appreciate you guys taking the time to listen to what I had to say today. I hope it was helpful. Please feel free to reach out to me at my email there. I also check the community as well, so you can send questions and things in there. Or if you have ideas or things you want to hear about and you're, just may not have the resources where you are or something like that, or maybe something you have coming up and you want me to think about it too, because chances are I'm going to be teaching it as well in one of my 3 physical sciences classes. So just let me know, and I appreciate it. And y'all have a great day, and I will see you next time.